This is being coded. Okay. Wait, not now. Okay. Guys, can you see the Q&A part? Have we checked it?
Yes, I can see.
Yes.
Then we can start in maybe next 2 minutes or so. It's people coming in. Okay, we'll just give it another minute and then we'll be starting off the sessions. I think we'll start off. I think we have the participants coming in, but in being conscious about the time. So I think we'll kick off this session. First of all, a very good evening to everyone. And thank you so much for your participation. Welcome to Data Science on the Rocks. And my name is Sanjay. I'm from the talent engagement team for Diageo. As you all know, Diageo is one of the most renowned producers of the world's most famous premium brands of wine, spirits, and beer. So what we're going to talk about today is the impact of data science in helping organizations to realize their strategic vision. As we all know, at these hard times as well, and any company in its way to stand on its top, and how important data plays in that journey. So here we're going to talk about it, not in an elaborate way, but in a very brief and an impactful way. We have two key speakers, Shashank and Kshitij. Just a a view about them before we get started. Just hold on. So Shashank and Kshitij both are the global leads for our advanced analytics and the data sciences team at Diageo. So each of them manage each of those segments in the data science category. Just a minute, I'm just kind of not able to move the slides. Just a sec. Yeah. Sorry about that. Yeah. So yeah, about the speakers for a bit. So Shashank, yeah, with over 13 plus years experience, he actually manages and leads the data science divisions, especially focusing on the consumer marketing, digital marketing, and also the commerce and finance part of Diageo. So he manages a good amount of team at a global scale and comes with a lot of experience in the AI, ML product lines across industries. Our next speaker, next slide. Yeah, our next speaker is Kshitij Mathur, who's again, from the supply chain domain with over 13 plus years experience. He also forms a part of our key agenda in the advanced analytics and data sciences. He manages a team that actually focuses on the supply chain management and analytics for Diageo. So before we get it started, moving on to the next slide. This will be a very brief agenda that we have. So the introduction, which I'm giving from my point of view, and what we will cover in the span of next 40-45 minutes is a brief touch up on the CPG organization, how it works from a data standpoint, and the journey of how it starts and how it ends. And slowly it touch bases on the impact or the strategic data science impact, mostly revolving around the market evolution side of it. And the key thing, how we understand the problem and how we counter the problem with proper modeling techniques and how the results finally look. Most of these scenarios are taken from real-time basis, which will actually keep the content very relevant. I know the participant numbers are participants are varying with experiences from 0 to 10 years mostly, but we have kept it as elaborate and simple as possible. And the second part, which is actually taken by Kshitij, will focus majorly on the manufacturing process, basically the digitalization of ideas. How do we optimize manufacturing in this digital era? And also slowly moving to the throughput optimization. And finally, the takeaways from the session. So this is what we're going to expect. Before that, a bit of housekeeping over here. I'm sure there will be questions from the participants. Please use your Q&A tabs to kind of put in your questions. I'll be able to collate in the best possible way. I know we have limited time, but I'll try to collate as much as questions as possible. And at the end of the session, we'll have 5 to 10 minutes to kind of answer. We'll have Kshitij or Shashank answering the questions that are relevant to their topic that they're handling. So please use the Q&A sessions, the Q&A tab to put in your questions as it goes by. With this, next slide. Yeah, Shashank, over to you from here on.
Thank you, Sanjay, and warm welcome to all of you. So maybe if we can go to next slide, I'll take you through the journey. So before we begin, let's first understand, like, Diageo is a CPG organization. CPG is a consumer product goods, consumer packaged goods, sorry. And here, like, before we even try to understand, like, what are the kind of problems we face and how do we apply data science to solve those problems, let's first get a brief understanding, like, how does this consumer packaged goods industry work. So basically, what do you understand by consumer packaged goods is, like, you sell the products to the end consumer. So something like, if we talk about Diageo, our alcohol beverage products, if we talk about some companies which sell your toothpaste, detergents, and biscuits, snacks, and all that. So those are all CPG organizations. Now, how all of it starts. So basically, we manufacture those product lines in our factories, and then through the logistics and distribution network, we pass on those products to our distributors, and then from distributors it does go passed on to the retailers, and from retailers the end consumers like you and me go and purchase those products. And with the evolving era, these retailers are online, offline, both ways. Now, what is so this is how, in a very brief manner, how a CPG organization work. Okay. Now, the data science as such is increasing its footprint in the way, like, it transforms the various processes involved inside these steps. And along with, like, BFSI and telecom, we are one of the early adopters of these data science related changes in the game. So next slide, please. If we can go to next slide, please. Okay. So from a CPG perspective, like these are not an exhaustive, but some of the key problem areas where we can apply data science to create a strategic impact. So the thing is, like, data science is intensive work, and we want to put in efforts where the returns and gains are maximum. Okay. So like these are some of the areas where data science can create a very good and strategic impact. Some of them are like, you are a CPG company, so you would want to understand and track your market evolution for your category of products altogether, and you want to do it preemptively. You want to predict that changes, and take your align your actions accordingly. Similarly, you want to improve your consumer experience, through understanding the consumer behavior. You also want to probably increase your retail or e-commerce traffic footfall in your retail stores or your e-commerce sites, and you also engage in a lot of advertisement and promotion. So you want to probably improve the campaign response time and response return on investment. You are also, you have stores, and if you would also want to predict, optimize the store inventory. What kind of products should I hold in which stores? And by predicting, what are the products that are likely to sell in a given demographic area in a given store. Okay. And on the manufacturing and supply side, maybe you want to just improve your factories, minimize your factories downtime through some predictive maintenance. So these are some of the problems that any CPG industry, any CPG player would typically face. So we'll pick up, one of these problems and discuss in detail, like how we go about solving these problems through the use of data science. So if we can go to next slide, please. So before we even talk about data science problem or any problem, the most important aspect is to first understand and model the problem, not jump at any solution or any off-the-shelf algorithms. But first, the basic step is to understand and model the problem. Now, let's say we talked about 7 problem areas. Let's pick up a chunk of problem that we want to understand and solve. So the thing like I'm picking up is, for the session I picked up is the, how consumers are interacting with our category of products. What are the, latent trends that I can detect from this interaction? And can we identify some, evolving taste and preferences of the consumer, and, understand it. So now the question is like, if I'm able to answer these questions, what are the what are the impacts I can make? So one thing is like, if I'm able to answer these questions, I can, make an impact in 2 ways. One is like, tactically I can, from a marketing standpoint, so I can tailor my marketing communications. So whatever advertisement and promo spends that I'm doing, and whatever the content of those advertisement I'm making, I can tailor that according to the answers that I get for these questions. In a strategic vision, if I know, if I understand, like, there are some products that are, there are some taste and preference that are being evolved. So for a company like ours, who play into like the food and beverage sort of space, we can, bring out some innovative and new products altogether for end consumers. And we know that, these are going to be successful because there is a latent trend that is going to grow. Okay. Now, we have identified the problems, and we identify like what is our end objective through that we want to solve through these problems. The other step would be like, what are my potential sources of, these organic interactions. So maybe I just pick up, there are a lot of them. For the sake of simplicity, I just pick up some social digital platforms like Facebook, Instagram, Twitter, and, Pinterest, and things like that. Now I have understood. So there are some, when I pick up these data from these platforms, there's a lot of inherent noise. So I'll talk about them, like how do we clean up all those later. But let's say we've, for the sake of simplicity, we've cleansed up all the data, and then, we now want to understand, if we look at these problem, so are these a supervised class of problem, supervised problem, or an unsupervised problem? Clearly this looks as an unsupervised problem, because I want to discover here. Okay. And this again, when you have an unsupervised problem, a natural instinct that comes to your mind is, go ahead and pick up any clustering algorithm. But should I do that, or should I not? Or should I go with the topic modeling? And again, as a data scientist, you would spend some of your time in reading through the algorithms and understanding how they work, and then you'll with some, let's say you do some Google search and find out like, okay, you know what, with this kind of thing, its topic modeling is much sophisticated and state of art. Okay, and again, in topic modeling, should I select LSI, PLSI, LDA? Let's say we decide, we go ahead with LDA because that's the most sophisticated one. And again, now, should I, when I apply, should I, learn that algorithm and then apply on my problem, or should I apply and then learn? So the conundrum here is like, if you do not learn the algorithm and straight away apply to your problem, it will be a truly unsupervised learning, because you really don't have an idea how how the results are, how the end results are going to be, and why the results are the way they are coming out. So we do a kind of a iterative, we learn, we understand the algorithm, we apply, we then fine tune, we iterate. So that's an iterative process. Next slide, please. Next slide, please. Yeah. So now we have, let's say we have shortlisted, latent Dirichlet algorithm. So that's a probabilistic algorithm. And before we dive into like how that algorithm works, we probably want to first, refresh some of our probability concepts. So like there are like some of them as like binomial or Bernoulli distribution. It's nothing but a coin toss where you have, one result at a time. So you have to estimate one parameter, like probability of heads and the heads or tails. Okay, then there is something, an extension of that is a categorical or a multinomial distribution, which is the example, classic example of that would be drawing the balls from a bag. So you have, let's say, red, green, and blue balls, and you pick up and draw a ball. So you have n-1 parameters to estimate, because you have like, n balls, and like the last ball you pick up would be 1 minus all the probability of all the drawing all the other balls. Now we've understood this, and then what is a Dirichlet distribution? So it is nothing but the distribution that generates this particular bag, bag of balls. So like it tells you how this bag should look like. Okay, so we'll understand, how and why this concept is useful in the latent Dirichlet algorithm topic modeling. Next slide, please. So now, let's say we have some, assume like we collected some 10,000 messages. Okay. Now those messages are nothing but a collection of themes. If I just put it in a very simple analogy, these messages are, there's one bag of messages, which is a collection of themes. And then theme is another bag, which is nothing but a collection of words. Okay. Now, you are seeing something called alpha and beta here. These are nothing but the parameters, which are the since this is a probabilistic algorithm, we give them some prior probability that, okay, I understand like what should be my word distribution inside a theme, and what should be my theme distribution inside a message. I define them through beta and alpha respectively. Okay, next slide, please. So now let's just open up this algorithm and understand like what is the model, what are the parameters, and what are the variables that we need to choose. Since this is an unsupervised learning algorithm, we want to select, some we have to initialize some parameters initially. Okay, so we choose like the number of topics we want to discover, and these alpha and beta parameters. Okay, which is nothing but the per topic, per document topic distribution, prior distribution of per document topic, and beta is nothing but the prior distribution of per word in the topic. Okay, these are the initial parameters which we initiate, and let's say we have m documents and n words per document. And what we arrive at, we try to estimate, what we are trying to estimate is theta and phi. So phi is nothing but the probability of a word given topic, and theta is the probability of topic given a document. Okay, so these are nothing but these two are the parameters of Dirichlet distribution that will be trying to estimate. Okay, and how do we do that? Let's go on the next slide and I'll explain. So now, I mean, if we just break it down, so we told like, okay, theta is like probability of topic given document, and phi is probability of word given a topic. Now, what we have to do is when we have to estimate probability of a word given a document where it is, and that's how we create the set of topics. So this is nothing but it's a joint distribution of theta and phi. And if we put a independence condition, what we get is essentially a sort of matrix of theta and phi, and we have to just multiply them to get the final word, which word belong to which topic in a document. And what we have to understand now is to learn this weight of these two matrices, because when we multiply these two matrices we get the final topic assignment, the conditional probability. Okay, so now how do we learn that? The objective here is to maximize the likelihood of our, so we have our data there, and we have to maximize the likelihood of achieving that data given this theta and phi. So we have to work on this theta and phi matrices to understand how we can generate that set of documents that we have. Next slide, please. Now, let's first get a perspective like how complex this problem is, the estimating the parameters. So far we have seen like we have two parameters, we have some initial values defined, and then we have to just multiply those conditional probability metrics and estimate those values. But is it that easy? So let me give you a perspective here. So let's assume that we had, we want to understand four themes from the set of messages, and let's assume we have 10,000 messages. So like the parameter theta, so for we have around 40,000 parameters to be estimated for theta, the matrix size of that theta matrix. And for phi, let's say we have 5,000 unique words in those messages, and for themes, so we have around somewhere around n minus 1, so around 20,000 parameters there. And then again there's something called word assignment of topic, where we have, let's say we have 50 words per topic, so we have around 500 500,000 words. So essentially we are trying to estimate conditional probability, the right set of values for around these 560,000 parameters, which generates this current set of 10,000 messages. This is a posterior joint distribution estimation that we are trying to do. And with this amount of parameters to be estimated, this is a really hard problem. So, but there's something that is to our rescue. There's something called Gibbs sampling algorithm, which will help us navigate through this problem. And let's go to the next slide, please. Now, here we know the objective is like, assuming that we know theta and phi metrics, we have to maximize the likelihood of our data given these two matrices. So what we do is like, we don't know anything. So we just assign all the random values to this theta and phi. Okay. So essentially we are generating these two random matrices of this theta and phi dimensions. And then what we do is we keep one value, we take one value, keeping rest of it constant. We try to estimate one value, and we check with the evidence from the actual message, and that's how we try to allocate topic to each of the words. And once this parameter is fixed, we go to the next, and so on and so forth. Repeat this process for all the parameters, and then we do it a number of times. We repeat this for a number of iterations. So there's a mathematical guarantee that this will bound to converge, and we are likely to get a maximum likelihood estimate there. So let me just explain you with an example there how it works. Next slide, please. So let's assume like we had a message called India enters a World Cup final. Okay. And we randomly assigned some topic initially, like we assigned topic 1 to India enters, we assigned word enter topic 3, world and topic 1, cup and topic 2, and final. So then we create a count matrix. This is the theta matrix that we are creating. Okay. Which is like where we are now this is the word number of times a topic uh, you know uh, topic, any topic uses a given word. So this is the frequency we have assigned at random, and then again another count matrix, which is the 5, which we have assigned here, with the document, like in a document how many topics come up. Okay. And then next slide, please. what we do is like we just rearrange, we just remove, we just change one number in one of the, for example, we pick the word world, and we reduce the count from 28 to 27. We don't know, we still don't know which topic it belongs. We just do this matrix, we keep this matrix and multiply this matrix, and we just multiply and try to understand what is the highest conditional. So we do it for a number of iteration, and then we kind of try to get what is the highest conditional probability. So after doing it at a lot of iterations, we are likely to land up in a that final matrix, which gives us the highest conditional probability, joint probability distribution. Okay, next slide please. So now, I mean, we've talked a lot about the maths behind, and the thing is, like, in the organizations, you have to put it into work, into an actual work. So how does this entire thing gets converged into a technology framework? Because that's, at the end of the day, you have to deliver results and you have to deliver insights. And how does that work? So what we do is, like, we take a raw data source, and we probably use some APIs from Twitter. There are some powerhouse APIs available, free and paid as well, where we can extract data from. We can even write our crawlers to extract those data, those raw messages. We store them. We store it, use a cloud or maybe an on-premise server to store them, and then the next step is the text cleansing. That's the most important part here, before we apply, because we have to give it the right data set. So what we do is basically we remove all those common occurring words, stop words, which are commonly referred as stop words, and then we lematize them, reduce the words to root words and all that. And then we have also do some data wrangling in the sense, like, we have to have the time slots when those messages were posted, by whom those messages were posted, and kind of some metadata around those messages. Okay, what was the location of those the messages were posted. So these are the metadata, and then we pick up the messages, run through our topic modeling algorithm. Now let's go to next slide, and then we'll come back again to the slide, like what happens. So next slide please. So now there was some parameter initially that I talked about, alpha and beta. So I didn't touch upon detail, but let me tell you, like, here those alpha beta parameters are the initial prior distributions, and if you keep a very large value, it means, like, it will be a uniform distribution. And by uniform distribution, I mean, like, if you are seeing the results here, you have every topic has almost every word, you know so everything has and that actually cannot be. In a message, you can talk about maybe one or two things at a time, but you cannot talk about everything in all the messages, right? So what we do is, like, if we just reduce those values of alpha and beta to very less values, we now see some sensible results here. So if we see, like, topic one, the words that are there, it kind of tells about craft brew. The second topic tells about maybe some party and in the bar and restaurants. The third topic is maybe some chilling out on the vacation and things like that, and topic four is more about food and flavor pairings. So now the thing is that since we have these words identified, and the topics identified, the top words identified, and we also have the time when messages were posted. So now we've converted this unstructured data into a structured time series. And that's when, if we can go back to the previous slide, that's when now we can apply any forecasting algorithm to understand, okay, what, how this, let's say we figured out a flavor of coffee. So coffee is a very prominent flavor in beer. Okay, so maybe we want to understand how is that going to likely to look in the near future. I can apply, and now that I have converted those word mentions, those topic and those word mentions into a time series, I can use any forecasting algorithm and forecast, like, for next 6 months or next 1 year, how does that look? And I can probably create marketing communications accordingly, or maybe bring a new coffee infused beer. Who knows that? Okay, and this is where, like, on the visualization layer, we show, like, how the insights look like. Okay, now all of it is underlying is, you have to have an execution engine which kind of runs all this through and runs it. every time in a perfect manner there. So this is where all the engineering comes in please, and you deliver the end product, and machine learning product, which which is kind of extracting data from raw unstructured data and giving you an insight like which you can action upon in terms of marketing communications or strategic product development. So that's all I have for now, and thank you for all for your time. So maybe we give it to Sanjay back. I'll give you back, Sanjay.
Hey, thanks, Ushank. Pretty intense, and yeah, pretty much knowledgeable in terms of it. I hope this will give really true insights on the way forward, and actually talking about market evolution and the journey of data from raw data to making something sensible of it and how it all churns out. Without wasting much time, I'm just going ahead with the next speaker, Kshitij Mathur, who will actually delve. If Shashank spoke more on the market evolution on the consumer side and the data side, Shishik will speak more on the supply chain management side of it. So let's hear from Shishik.
Thanks,
Go ahead,
Sanjay.
Kshitij, it's all yours. Yeah.
Thank you, Sanjay. So folks, thank you very much for joining this webinar. And today I will like to take you through about the manufacturing process, some insights on the industrialization 4.0, its association with wearable technologies, automated guided vehicle machines, and what kind of problems could be solved by application of data science in the real manufacturing. Can you please go to the next slide? Now, in the manufacturing process, there are different application of the manufacturing processes. For ease of our understanding, I have taken an account of water purification and bottling plant. Now, in this process, let's understand that we get a raw water feed. We have a RO water treatment plant. It converts into using the reverse osmosis technology, it gives you the pure water. There's a water wastage of the not used water. And then the pure water goes to the water filler, packaging and bottling, and then it moves on it. Now, how does data science come into picture here? What can we do it, or what are our core problems in the manufacturing at this point of a time, which could be solved in a non-conventional method? Let's think about it. If my plant is running up and fine, and all of a sudden there is a breakdown, what happens? The production line stops. Let's go one more level down. Let's talk about a water pump, or let's talk about a motor. So if you think about whenever a liquid movement happens, it happens through the pumps, or a solid movement, either it's a conveyor belt, it again happens by the motor. And what happens if that motor breaks down? Yeah, we will be having some spare, but it will need some time. And that time wastage is basically the value lost in that particular plant. Now, is there any way that we can find out that how and predict when that particular breakdown may happen in future? Yes, of course, there is a way. Now let's go into much more basic fundamentals. Is that how does the motor work? A motor is a mechanical instrument which has a rotatory blade with a coil surrounded by a magnets, and when you pass an electricity, it rotates. Now what happens? There are different parameters here. There is a current, there is a insulation, there is a resistance, there is a heat, and these are basically industrial machines. So they are exposed to the external temperature. So you have the weather conditions, you have the temperature, you have the geographic conditions, humidity, air pressure, and all those phenomena. And this will have a definite impact on that particular motor. Now, I hope you guys remember something about acceleration, which you might have studied in basic physics, which is basically whose unit is basically meter per square second, and it will tell you, and that particular acceleration can be measured from this motor, which is basically the vibration and jerk. Now, imagine a scenario where the motor is running round and round. It has some kind of a cycle. And that cycle, when you capture from the accelerometer and you plot that data, you will see that it has some kind of an amplitude, it has some kind of a wavelength. And that basically data set or a wavelength can be used for our analysis in a data science. Now, whenever that data set or data distribution gets distorted, Maybe because there is a broken blade, maybe because there is an added weight, maybe because there is a change in the current or atmospheric temperature or pressure, the data distribution changes. And once we know this data, we can quickly identify when this data distribution changes. What is the probability of happening the change in the next couple of hours or in the next couple of days? And using that, then we can come up with some kind of a mechanism. We can calculate mean time between failure. We can come up in some, we can extract the insights and transpose those insights either in some kind of a visualization tool like a Power BI, ClickSense, or we can send that signals to a PLC where the system can take the action on its own, or we can send it to the control tower. Now, if you think about this entire case, where the problem was unplanned downtime, and you see how a data science can solve that particular problem. Let's think about a linear regression. Linear regression is the fundamental block. Now we can use the linear regression to solve this problem where you have the multiple variables, you have the target, and then using this linear regression, you can come up, you can say is that when the downtime may happen or when it will happen, when it may not happen. So folks, please see that how this basic mathematical equation can help the business to drive and reap its benefit. Now let's go back to the second example, which is the throughput optimization, which is basically one of the, where we will be going in much detail in the next couple of minutes, which is more about the efficiency improvement of the RO plant. Now, as I had earlier mentioned about industrialization 4.0, sorry, where there is a lot of tech heavy usage of automated guided machines. So how these motors, how these trucks moves inside the warehouse, nobody is controlling it. And these machines are generating humongous amount of data. So that, and then if you are having a variable technology, so if there is a downtime or unplanned downtime happens, all the signals can be given to the operators who can take the decision in the right moment. Now there is a image processing can happen when a filler is filling, or let's say assume that a bottle is not tightly is not capped tightly. That minute incidents can be recorded from the image processing, and those images can again be understood by application of a deep learning or a machine learning, and it can tell you in the different scenarios which is the right case and which is the wrong case. Now going into much detail about the throughput optimization, may I have the next slide please? Now throughput optimization of that same RO machine. So the output is basically the yield. So we have the input, which is the raw water, and then you have the output, which is the yield. And in order to that, there are different other constraints. So feed water, which is your water feed, water flux, which is the rate, pressure, temperature, and tolerance. Now, what are we trying to do here? We are trying to build an optimal, a fundamental block of an optimization using these individual constraints, and then come up that how can I make certain small changes in these constraints so that I can increase my optimal value or my optimal result. There are various techniques of the optimizations. Could start with your Bayesian optimization, linear optimization, stochastic optimization, operations research. For ease of your understanding, I will just go into the basic fundamental block and explain you how that optimization logic works. Can we go to the next slide, please? Thank you. Now, let's think about a canonical form of optimization. We want to increase our yield, which is our objective function, which is where the mathematically we are writing about C transpose matrix into X, where X is basically represents the vectors of variable, which is to be determined. C and B are the vectors of known. Basically, these are the coefficients. A is the matrix coefficients, and X, where we are saying all the variables should be greater than 0. And the Z, or we call C transpose X, is basically the objective function which we want to do the maximization. Now, under these inequalities condition, we are trying to build a convex polygon which will basically provide us the optimal result. May I request you guys to look on the left hand side of the graph where we have the different constraints marked by the different lines, and these constraints have different ranges. Whenever there is a sectional cutoff between these different constraints, it will generate an area, a polygon, or of any shape. And this is where your optimal solution lies. What we have to do is that, what is the best way? What is the best equation? What is the best expression of the values inside that optimal region or optimal solution, which gives you the end result. If you want to imagine in a three-dimensional aspect, if you look on the right-hand side, imagine it as a sphere where you have the different constraints bounded by the different regions and you have a tangential. There, again, we are talking about the same objective function. So folks, what I'm trying to explain here is that they are the different problem statements. They are the different potential areas where we can apply the analytics or data science or machine learning or deep learning. I'm trying to show you a small example about an optimization modeling and how can we solve the RO problem. May I go to the next slide, please? Thank you. Now, if you see, this is the optimal solution. This is just an illustrative in nature. We had different output, we have the different inputs, we have the different constraints. And what the optimization model has given is that if you operate at this level, then you are going to have a delta increase in your production rate. And this delta value is the value benefit, because this is what the business is aligned behind it. Because just understand one thing, without making any much major changes, any much major drastic change in terms of the process or anything, you are just making some fundamental changes using some mathematical equation, and that is going to give you the benefit that is going to increase either optimization or in any other kinds. Some of the other example is that if you think about how the CPG industry works, so let's take an example of a roll-on, roll-off, where the product is manufactured at location A, it's sent to B via, let's say, a truck mode. Then from B to A, it's sent by a rail mode, then a ship mode or a air mode. Now, suppose somebody wants to calculate the total cost to serve or total cost to deliver. How will you do that? How will you come up with what is the maximum retail price of a product? Because that will tell you the baseline for for your bottom up, for the benefit of the organization. And that's where we can come up with simple optimization methods to tell you is that what are the costs, what are the different constraints, how to come up with an optimization logic, how can we tell you that what is the best result, and then you can use that as the baseline. Can we go to the next slide, please? Before we close this webinar, we would like you guys to pay some little attention on what exactly could be the takeaways. One is about data democratization. This is one of the important things, because as I gave the example right now, or my colleague Shashank explained earlier, there's a huge data which is getting generated, but can we use that raw data? So what we need is that to think from both the bottom-up approach and the top-down approach. We need to make sure that the business leaders can take their decisions on their own, which is mostly driven on the data and in a scientific manner. So what it needs some kind of an investment in terms of building a data lake, in terms of doing a high level of data reporting, in terms of integrating the different systems. Then only we can get the holistic picture, and based on which we can take a pan view of the organization. Data science is an essential differentiator. Since we understand that the pan view of the data lake will give you the sufficient information, the data science will add as a catalyst to extract more information, insights, and value to the organization. One of the most important things for any project and success is change management and sponsorship. There should be a constant buy-in. There should be a constant support by the business, by the stakeholders. There should be an understanding that whatever the recommendations which comes out from the data science or any of the project should be easily transferable in the processes. In the processes, it could be a process, could be any strategic business, could be a finance process, could be a marketing or a commercial or supply chain processes. But till that time, those information, those recommendations are not translated, not implemented in the workshop, in the processes, in the strategic business unit, this particular exercise remains an academic. And that's why in order to gain the value for the organization, a change management sponsorship plays a vital role. We as an individual either if we are as a student, or we are as a product manager, or we are a stakeholders, we are a data scientist, data engineers, in any role what you guys are, please keep value factor in the mind. What is the return on investment? I would suggest, if you think about, if you, even if you write a linear regression or if you write an equation, keep the value factor in mind. Monetary benefits, maybe just by making small changes in the coding, you can decrease the cost on the servers, you can decrease the cost on the infrastructure. Or the value benefit is that if we provide these solutions in that scenario or in the different scenario, how is it applicable to the business? Because the business acceptance is the most important thing. And the last I would like to say is that, guys, the most important thing is to build a strong foundation in probability and statistics, because that is the basic of any data science. The mathematics behind any algorithm, behind deep learning, behind machine learning algorithm. Also to pay some attention on design of experiments and operations research, because this will help you in terms of doing some machine level of optimization. Design of experiments will help you in those scenarios where there is no data. So we can conduct that, what are the best scenarios where we can do a data capturization, we can build a data capturation for those experiments, and then we can do the analysis, because that capturation will give you the real result of the entire solution. And we should also think about from the algorithmic perspective, from the problem modeling perspective. We should not directly jump to that. We know, okay, this is where we will use a logistic regression, a linear regression, or a stochastic regression. First, guys, let's understand what is the problem. How are you going to model the problem? Let's break down that business problem to a mathematical problem, and then take a judicious decision between which particular algorithm works well in that particular scenario. And lastly, we should also think about the application of best practices in coding. That how, just an example is that how you declare a variable. Your variable declaration should be in such kind of a camel case. How you writing your logics, your if or for loop, your while loop, because these are the basic things. Because when we are talking about TBs of data, a simple change in from for to while will have a major impact. Um, that's all from my side. Thank you, guys. Sanjay, over to you, please.
Hey, thanks a lot, Shashank. Very insightful. I mean, beyond all that algorithms that these that the decks were prepped with, and the kind of thought process that gets into executing, a problem to a solution is amazing. I mean, that's why Diageo, with its premium brands, the most world premium brands, um, you know, it is there for a reason, and data will play a key role there. Anyway, thank you so much for this. And moving on, I mean, we have a few questions that has actually popped up. Maybe I will just read it out. I mean, we just have some more time to kind of address it. I think starting with the first one, this is more to do on the data side. This is from Rama Srikant from Eastman Chemicals. When working on market research analytics, we generally procure data from third-party websites like IHS, or use web scraping to source data. What kind of strategies you have to get? What kind of strategies you have to get to relevant data on market trends, and what kind of insights that you draw from it?
Okay,
I
let me
think it
answer that
is,
question.
yeah.
Yeah. So, hi Rama. So the thing is, like, on it's a mix of strategy. So it depends on, what kind of. So for example, if we are doing it for some brand, maybe we use we use some third party providers who actually have done that scraping and API extraction and things, who can provide us the raw message. So we don't have to build the scraping engine and all, from the scratch. But if it depends on, if it is something like, not on the brand, but let's say from some occasions, so celebratory occasions and all, we may use some different strategy to extract the data, and we may not even go with the any data providers. Okay. And So the short answer is like it depends on the use case, actual problem that you are trying to solve. Okay. So now from a product design perspective, you have to build the product in a way that that the data acquisition part of this should be open, so and it should be customizable, where to use the third party service providers and how to connect to those, and if we are onboarding a new third parties data providers, how easily we can onboard them. Okay, that's the first part of the question. Second part is like what kind of insights. So again, I told you like the insights is, let's say let's take an example that we showed you. So one of the topic cluster was on the food and flavor pairings. So let's say we are seeing something like, okay, biryani goes a lot with the beer. Okay, so you know what, so some advertisement that you see around on the on your Facebook feeds or on your YouTube or on any television. Sorry, we are not supposed to advertise on television for alcohol, but let's say in other markets we do that, and then they say, okay, these are the, so it's something that the those creative advertisements can be made in a way that, okay, you know what, uh, these are so some story like, okay, these are the biryani and this is the best enjoyed by, let's say, XYZ beer or things like that. So that's how we apply those insights on a strategic way. And other kind of insights would be, let's say, okay, you know what, for example, I mean, an example that I gave earlier, like, okay, if coffee is a very strong associated flavor, so should I, so stout, if you understand, stout beer is a kind of beer which has a very strong coffee, coffee composition in it. So if should I, so maybe right now in my product portfolio I do not have stout beer. So I think, you know what, if it is good, it is growing, and it is not just a fad, it is going to be a long term trend. So it makes sense for me, like I know, like in next 6 months, this next 6 months or next 1 year, this is going to be big. So why don't I just, invest in a new in an R&D to create a coffee flavored beer or a stout breed of beer and introduce it to the market. So that's how, those are kind of insights that are derived from this, and that's how they're used in the end by the end marketers or the end product innovation people. I hope that answers your question.
Yeah, surely. Yeah, I think we are running out of time as well. We just have another five
Okay.
minutes for that. Yep. So thanks from Shrikant. Not sure, but we will try to respond to these questions over email. Trust me on that. But if we just have maybe another 4 more minutes before it gets disconnected completely. I think if I put any other more questions, it won't be able to complete it. But anyhow, I think we'll just wind this up. Anyway, thank you so much for your participation. We have got the remaining questions. There are around 3-4 questions that we're looking at. One question is regarding the hiring part. What do we look at while hiring? Well, I think Shashank, Kshitij, you will agree with me because I work with them a lot on the hiring part. A key thing that we look at is someone with a solution-oriented mindset. Someone will be able to think simple and use the best of technical facilities that is available to bring up with the best solution. I mean, that is what we look at in hiring anyone from associate to a VP as well. So that is maybe that is the key thing that we look at. But anyway, thank you so much for your time, and we hope to come back with more events, in the future. So thank you all for your time and your participation. Till next time. Thank you.
Thank you.
Thank you.
Thank you so much. Thanks.
Bye.
Bye bye.